Welcome to this explainer on prompt caching. Look, if you're calling the Claude API with a long system prompt, you're probably paying for it. 3, 4, or maybe even 10 times over. On every single call, you're sending the exact same system prompt, the same rules, the same massive reference documents, and you're paying to pass all of that data every single time. And because of that, the API has to reprocess it from scratch every single call. It's a massive waste of resources and money. While prompt caching completely changes that game, here's the deal. You just mark the stable part of your prompt once. Anthropic then stores that processed version. So the next time you make a call, it reads from that store. And the best part, that read costs just 1/10 of the normal rate. We're talking about a massive 90% discount on the part of your prompt that literally never changes. This isn't just some obscure tiny optimization. It's absolutely the single biggest cost lever you have on the API right now, and it only takes a few lines of code. That's really it. So how does this actually work? Let's break it down. Think of your prompt as having two main parts. First, you've got the stable part. This is your system instructions, rules, tool definitions, and maybe some big reference documents. Then you have the dynamic part, which is usually just the user-specific question. Now, without caching, the API reads both of these parts every single time. And most of your cost, yeah, it's hiding right there in that massive stable part, which conveniently is exactly the part you can cache. To do this, you just add a simple flag called cache control directly to the stable block. It essentially tells Anthropic, hey, hold on to this for me. Specifically, you set the type to ephemeral. Now, just a heads up, that's actually the only valid option available right now. It just means store this temporarily, not permanently. So on that very first call, it writes the block to the cache. Then, for every call after that, as long as the prefix is identical, it skips the heavy lifting and just reads straight from the cache instead. So what does this actually look like when you're writing the code? It's unbelievably simple. It's literally just one extra field. All you do is wrap your system prompt in a list, and then you pop in that cache control object with the type set to ephemeral. And yep, that's the whole shebang. But okay, there is a catch here, and it's a really important one. The prefix, basically everything right up to that cache control marker, has to be exactly the same on every single call. I don't mean almost the same, I mean absolutely 100% exactly the same. Think of it kind of like a folder name on your computer. Rules v2 and rules v3 are completely different folders, right? The system isn't going to look inside to see if the contents are similar, it's just matching on that label. If even a single character is different, boom, total cache miss. Because of this, the most common trap people fall into is putting something dynamic right inside that cached block. Things like a timestamp, today's date, maybe a unique request ID, basically anything at all that changes. If you do that, every single call forces a brand new write to the cache. You'll literally never get a hit. And worse, you'll be paying the write fee every single time, which actually costs more than if you had just ignored caching altogether. Luckily, the architectural fix for this is super simple. Any dynamic content needs to go after the cache marker. All your static, unchanging content goes before it. Got a timestamp? No problem at all. Just add it as a second separate block completely outside the cache. If you get this right, you unlock that massive 90% discount. If you get it wrong, well, you're actually going to be paying more. Now, there are a couple more things definitely worth knowing about the expiration. The cache does expire. The default setting is 5 minutes. There's also a 1-hour option you can use, though that one does cost a bit more to write. But here's the really cool part. Every single cache hit actually refreshes that timer at 0 extra cost. So if you've got a busy app with lots of traffic, that 5-minute cache basically stays alive indefinitely. You literally only pay to write it once. The 1-hour option, on the other hand, makes a lot more sense for slower workflows, things like batch jobs or internal company tools, stuff that gets called maybe a few times an hour rather than a few times a minute. All right, the very last thing, and this is absolutely crucial, you have to always verify that it's actually working. When you get your response back, it includes a usage object. You want to look closely for a field called catch read input tokens. If you check that field and it says 0 on a repeat call, yeah, your cache is not hitting. There are a few common culprits here. You might accidentally have a timestamp hiding inside your cache block. You might be under the minimum token threshold required for whatever model you're using, or your cache might have simply expired. You've got to check this field every single time. Please don't just assume it's working. So at the end of the day, the execution here is really straightforward. Just mark the stable part of your prompt, verify your hit rate in the usage object, and pick the right expiration timer for how often your specific app actually calls the API. There's no complicated setup here, no crazy special architecture required, literally just 2 fields and a quick check. The real-world savings here are staggering. If you've got a production app running a 50,000 token system prompt, you can easily drop your latency from sluggish seconds down to snappy milliseconds. And your costs? Those go right from dollars per call down to mere cents. So I highly encourage you to try this out on your very next API project. Just remember to check that usage field after your first repeat call. The real question is, does it hit?